coming up right now is the Space Show.
This is your community radio station, 88.3 Southern FM.
Did you see the eclipse last night? He's grabbing the microphone. I sprung this on.
No, you're all good. No, missed it. Had to look at the Google photos this morning, which were pretty stunning, so I was a bit gutted I missed that. You got out to watch it?
Yeah, yes. Because what happened was it's been cloudy for days and days, and I'd given up hope almost. I telephoned my brother in New Zealand and said, hey, you've got to go outside and look at it and take some photographs for me because we're not going to see it here in Melbourne. And guess what? Yep. Just before the eclipse started, the clouds dissolved, evaporated. They didn't move away, they just evaporated. Although I could see that out east towards Dandenong, there was still some cloud, so those people out there wouldn't have seen anything. And it stayed that way until after midnight. And the sky was clear because the rain we've had recently has cleared the dust out of the air, and so the stars, you could see them even better than normal. And, yeah, it was great.
And I saw it was over, like most of Australia had pretty good views, so WA was great and South Australia was great as well.
Right. And guess what? My brother in New Zealand, he took me a couple of photographs and he sent them, but he said it was partly cloudy. There was through thin cloud.
Got it.
And I'd spoken to him an hour before and said, hey, look, it's cloudy, it's not going to clear up.
Yeah.
And it did.
Very nice.
So there we go. That was the eclipse. And this is something unusual. You know, when you look at the moon, and the sun, in fact, as well, it just looks flat, like a flat disk. But the lighting of it around and so on, it made it look spherical.
Yeah, okay.
It was an optical illusion, obviously, because you've got no parallax with two eyes from Earth. But it looked spherical, and it was quite an unusual optical effect. So anyway, that was the eclipse, yes. We did tell you when to see it last week. We told you about that, and yes, it happened here in Melbourne, and at least some people in Melbourne got to see it. Although others may have been clouded out. All right. Now, our first item is on Saturday, Rocket Lab launched an Australian hypersonic aircraft. It's called Dart AE, and the craft was built by Hypersonix Launch Systems in Queensland. That's Hypersonix with IX, not I. Hypersonic. Okay. Here's a little promo about what that company does.
The time is right for hypersonics. The purpose of hypersonics is to build and fly hypersonic aircraft. We are out in front in terms of our scramjet technology, so the propulsion, but also our vehicle designs.
We believe it's going to change the way we fly. It really is about that technology as much as the application of that technology. What we develop here will have wide-ranging applications across aerospace.
We have this long-term target of flying at Mach 12, and at the moment, Mach 12 for sustained flight, it's kind of in the realm of science fiction. So what we need to do is break down that path to flying at Mach 12 into discrete milestones. The first of those milestones, the first flight activity that Hypersonix is going to perform is DART at Mach 7.
When you travel hypersonic, the main issue is heating.
DART will be glowing red hot and 1,000 degrees, but we have to keep the sensitive electronics on the inside at under their maximum temperatures, and we don't have very much space to do that. DART is a demonstrator to fly at hypersonic speeds, but it's also to collect data and to learn so that we can keep pushing forward and make vehicles that travel up to Mach 12.
The thing about flying fast is you always end up with a really cool looking plane. We've developed this scramjet technology and hypersonic vehicle technology over the last 30 years. So it's come together, it's very mature. And then we have all these other opportunities of new materials, the commercial off-the-shelf hydrogen tech, and the computing power that we use in our analysis.
We are literally creating a new category of flight. By air breathing and not carrying oxygen on board, we're increasing the mass fraction that we're able to deliver to orbit.
Hypersonics is on the cutting edge of not only the product in terms of hypersonic flight, but also the regulatory initiative to try and integrate this vehicle into national airspace. The growth potential is tremendous.
Designing and building an aircraft that can fly to Mach 7 is hard, but we are dedicated to getting there and pushing beyond. And we're not doing that alone. We have a very wide hypersonic ecosystem of partners.
We've got the best partners on the planet to help us do that. We're dealing with partners such as Kratos, DIU and Rocket Lab.
We also have a lot of smaller companies here in Brisbane, but also throughout Australia that help take our tech from the design to the real physical thing.
In order to fly at Mach 7, we need to overcome a whole bunch of engineering and materials and technology challenges, and what we're working on at the moment are tackling those challenges one by one.
We've got the team, we've got the technology, and we've got a way of being able to build what we build in a high cadence. And I think that's why organisations like the Defence Innovation Unit, that's exactly why they deal with people and companies like us, because we can move a lot faster.
The goal at Hypersonics is not just to enable hypersonic flight, but to commercialise it for everybody.
It's for the planet. I think we're building a platform using hypersonic technology, particularly scramjet, that are hydrogen powered, and we're looking to deploy that technology across various aerospace applications. We see the planet as the beneficiary of what we're doing in the longer term.
No, it's never easy, but that's what makes us unique, and that's what puts the X in hypersonics.
And that feature was supplied to us by Hypersonix Launch Systems in Queensland. Well, the launch was made from Wallops Island on the eastern seaboard of the United States. Here is how their broadcast began.
It's a crisp afternoon over the eastern shore today as the countdown continues to our latest mission from Rocket Lab Launch Complex 2. You can see our HASTE suborbital rocket right there on your screen, getting ready for liftoff from the Mid-Atlantic Regional Spaceport on Wallops Island, Virginia. Now, just minutes away from launching our next hypersonic test mission for the Department of War's Defence Innovation Unit. My name's Hannah Jury, and it's great to be here with you for this exciting experimental mission.
And my name is Muriel Baker, and we are just 21 minutes away from our target launch time today of 4:50 p.m. Eastern Time. And things are looking good for an on-time liftoff today. The weather outlook is 90% favourable for launch, and we are green across the board for our HASTE rocket, the payload, and the range here at NASA's Wallops Flight Facility. And today we'll be taking the DIU's next experimental hypersonic mission to the skies to deploy DART-AE, a scramjet-powered aircraft developed by Australian aerospace engineering firm Hypersonix, with an X, and with a nod to their payload and Australia's classic cultural icon, Crocodile Dundee. We are calling this launch That's Not a Knife.
Today's mission marks the historic first flight of DART-AE, which will be used to validate the aircraft's propulsion, materials, sensors and guidance technology under real hypersonic flight conditions. At the heart of DART's 3D printed airframe is its scramjet engine, an air-breathing system similar to that of a jet engine. Now it uses oxygen in the atmosphere to combust with fuel, generating the thrust needed to fly at hypersonic speeds. This innovative design is part of Hypersonics' mission to create a low-cost, multi-mission hypersonic aircraft for applications in defence, aviation and aerospace.
The DART-AE is lofted into the upper atmosphere by an Electron rocket, a modified Electron rocket, and uses Hypersonics' Spartan scramjet engine, burning hydrogen fuel to reach speeds of 7 times the speed of sound. Well, here's how the launch sounded.
T-minus 20 seconds and counting.
Stage 2 tanks are pressed.
Stage activated. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff. Vehicles split pad, vehicles pad. Beginning pitch over.
Over.
Stage 1 propulsion is nominal.
Well, that's not a knife. That is our HASTE rocket on your screen there with a textbook launch off the pad at LC2 on Wallops Island. HASTE is climbing fast now at almost 900 kilometres an hour with an almost immediate pitchover to follow today's suborbital trajectory. Max Q, or maximum aerodynamic pressure, is up next. So standing by now with mission control.
Approaching max Q. Cleared max Q.
A nice clean sail through Max Q by HASTE there, now at speeds of more than 2,000 kilometres an hour. Hearing good calls from mission control as well. High voltage battery discharge should be happening as we need it to for those 9 Stage 1 Rutherford engines at the bottom of the rocket. And coming up soon will be MECO, or main engine cutoff of those engines, which is when all 9 of them power down at the same time. And now usually that is to allow for the first stage to separate from the second. But with this experimental hypersonic mission, we are doing things differently. And so at about the same time as those engines shut down, HASTE's fairing will separate and DART will be deployed to begin its free flight at hypersonic speed.
A reminder that at our customer's request, we'll be cutting the camera view just before MECO, fairing separation and payload deployment, but we will mark the moments we're expecting those actions to take place before DART AE flies the rest of the mission. So let's watch and listen now.
Stand by for MECO.
Okay, and with the clock now past 2 minutes and 45 seconds into flight, that marks our expected main engine cutoff, fairing jettison from HASTE, and deployment of Hypersonic's DART AE aircraft at hypersonic speed to continue on with their mission.
Right now, the team will be testing the aircraft's aerodynamic control at several times the speed of sound, as well as its scramjet propulsion to power the vehicle along its suborbital trajectory. Good luck to the DIU and Hypersonics for the remainder of the mission.
So HASTE's role in this launch is otherwise complete. Another hypersonic test launch with 100% mission success out of Launch Complex 2 on Wallops Island. And this is our second hypersonic flight for the DIU in just 3 months, and our 7th HASTE launch overall to test technology in those real-life conditions. This mission is also our 11th overall launch from Launch Complex 2 on Wallops Island within both the Mid-Atlantic Regional Spaceport and NASA's Wallops Flight Facility. So, congratulations and thank you to our launch partners for your ongoing support.
And since we're rounding out with numbers, today's launch is our 82nd launch in total and 3rd launch this year, with our next mission scheduled to take place in just a few days' time. But this time from Launch Complex 1 on the opposite side of the world.
Well, this was a test mission, but operational vehicles would be able to carry out high-speed suborbital intelligence, surveillance and reconnaissance. It could also be used as a rapid air freight flyer. Well, now, still in the United States, Artemis II. It's the plan to send 4 humans around the moon and back. Well, it's being delayed. The available dates now are in April for that mission. Why? Well, they had a hydrogen leak when they were fueling it up. And then they tried again and they fueled it up once more successfully, but then they had a helium leak in the cryogenic upper stage. So they had to make the difficult decision to roll it back 6 kilometres to the vehicle assembly building and disassemble part of the rocket and fix the problem. And they're taking the chance as well to freshen up some of the batteries and so on that would otherwise go flat. So they've got real problems. So the available launch dates at the moment as they stand is April the 1st, the 3rd, 4th, 5th, 6th and the 30th of the month. So those are the possible launch dates for Artemis II. A few days ago, there was a major change in the Artemis project to land humans on the moon. Jared Isaacman, the administrator of NASA, gave details of the changes at a press briefing, which NASA Public Affairs turned into a promotional message. Well, Space Association President Michael Abdullah has captured that message for the space show.
For 35 years, presidents have called for American astronauts to return to the moon. President Donald Trump took the first decisive step during his first term when he created the Artemis program. He recommitted to this endeavor when he signed America's space superiority policy, which not only calls for a return to the moon, but to build the lunar base and establish an enduring presence. This responsibility rightfully falls on the world's most accomplished space agency, NASA, to achieve. We have taken positive steps, but the moment for focus and urgency has arrived. In the weeks ahead, America will send the brave Artemis II astronauts further into space than ever before, around the moon, on a 10-day mission that will test the SLS rocket and Orion spacecraft before returning to Earth. As the plan stands today, the next mission you would see launch is Artemis II, which would attempt a crewed landing on the moon in 2028. Launching a lunar rocket every 3 years is not a strategy consistent with success. We are learning the same lessons because skills atrophy without repetition. In fact, across all NASA programs, from Mercury through Space Shuttle, this is by far the lowest launch cadence in the history of America's space program. The plan is not evolutionary in design, but instead reaches for a fully realized end state without building the foundation required to achieve it. In alignment with President Trump's national space policy and making the absolute most of the resources provided under President Trump's Working Family Tax Cut Act, along with the funding and support of Congress, we are altering the plan and bringing extreme focus to this grand endeavor. I'm pleased to announce the following. We will standardize the remaining SLS rockets to a near Block 1 configuration. We will strengthen our workforce and rebuild our core competencies in ground systems and stacking operations, bringing down pad turnaround times, and accelerate our launch cadence from every 3 years to every 10 months. We will pull in Artemis III and launch in 2027 with the aim to rendezvous with one or both lunar lander providers in low Earth orbit, gaining confidence in lander and XEVA suit systems. We will then prepare for up to 2 lunar landing missions in 2028. In the 1960s, NASA achieved the near impossible in an evolutionary way. We flew Mercury, Gemini, and many Apollo missions before landing on the moon. While we have learned much since then, with enhanced capabilities supported by the best industry partners imaginable, we cannot always jump straight to the desired end state. We need less needless complexity, less distraction, more launches, more operational muscle memory, and extreme focus on the mission. We gladly accept the challenge of returning NASA astronauts to the moon after more than a half century, and this time, to build a moon base to stay. This is the NASA that once changed the world. This is the NASA that will do it again.
Jared Isaacman there with that promotional message. And we're going to hear more from Jared after these messages here on the Space Show.
From Bayside, Melbourne, this is 88.3 Southern FM.
Where you're listening to the Space Show. We're discussing the Artemis mission to the moon. And they've made some changes, as you've just heard. Richard has queued up the press conference, originally straight from the press conference, from the media room. And he's going to play now what Jared had to say, a bit more than what we've just heard.
Thank you very much, George. Good morning, everyone. Appreciate everyone coming out. We're seeing each other a lot lately, lots of updates. Expect more of it. First, I just want to give a lot of credit to the NASA workforce and our partners that have been working really tirelessly through the Artemis campaign. It's really especially impressive work, and I know they're all feeling it after we had what was a near flawless Wet Dress 2 performance. That Artemis II is now back in the vehicle assembly building, which is imperfect. So we want to give you 2 sets of updates. Lori is going to speak with you about what we're learning about Artemis II now that it is back in the VAB, and what our path is back out to the pad and to launch this historic mission. But before that, I'd like to talk a little bit about the overall Artemis program. how we're going to achieve the president's objective to return American astronauts to the moon, to build an enduring presence, and ideally not wind up in some of the situations that we've seen recently. So let's talk about the situation. Artemis I launched more than 3 years ago. We had helium leaks with Artemis I. Artemis II went out to the pad. Wetros 1, we had hydrogen leaks, and then after a second Wetros 2, where we made a lot of great progress, we wound up with helium flow issues. A lot of similarities between the two, and why is that essentially the case? Look, 3+ year launch cadence. I mean, Artemis III right now, as it's currently designed, won't fly for approximately another 3 years. So launching a rocket as important and as complex as SLS every 3 years is not a path to success. A component of that is when you are launching every 3 years, your skills atrophy. You lose muscle memory. We've got a lot of really talented folks that have been working hard on the Artemis II campaign, and whether they're going to want to stick around for 3 more years after this mission is complete is a question mark. This is just not the right pathway forward. And I'd say also, when you are experiencing some of the same issues between launches, you're probably got to take a close look at your process for remediation. Are you truly getting the technical root cause, or are you getting close to it? So we've got issues with low flight rate. And I would say a great way to exacerbate that problem further is to start making changes to vehicle configuration. SLS is a very impressive vehicle. We don't want to turn every one of them into a work of art. And then I would also say that having very big objectives, a wide objective gap between missions is also not a pathway to success. So we didn't go right to Apollo 11, right? We had a whole Mercury program, Gemini, Apollo, lots of Apollo missions before we ultimately landed. Right now, our program is essentially set up with an Apollo 8 and then going right to the moon. And that is, again, not a pathway to success. So what is the right way forward here? So first, today we're announcing a standardization of the SLS fleet to what we'll call essentially a near Block 1 configuration. So the idea is we want to reduce complexity to the greatest extent possible. We want to accelerate manufacturing, pull in the hardware, and increase launch rate, which obviously has a direct safety consideration to it as well. You get into a good rhythm, launching great frequency, you get that muscle memory. In order to do that, we need to rebuild and strengthen the workforce here at NASA. Now, this is directly in line with a workforce directive that I released several weeks ago. We have to rebuild core competencies. The ability to turn around our launch pads and launch with frequency greater than every 3 years is imperative. Now, some people ask me questions on that already as we've talked about this, and it's like, how are we going to do that? How are we going to go from 3 years to something significantly less, to what I think should actually be inside of 1 year? And I'll point you to our history. We have a nice infographic that's coming out from Mercury, Gemini, Apollo through the shuttle program. I don't think it would surprise many of the folks in the room that our average launch cadence was closer to 3 months throughout all those programs, not 3 years. In fact, if you want a history tidbit, you look at the time when Apollo 7 splashed down to when Apollo 8 launched, you're approximately 2 months apart. We need to start getting back to basics and moving in this direction. So rebuilding the civil servant workforce and restoring core capabilities. Again, that will directly contribute to NASA's launch cadence, where we're going to endeavor to get our launches inside of a year, specifically down to potentially 10 months. And then we are going to add missions. In fact, we're essentially going to pull in Artemis III to launch in 2027 with a revised mission profile. So instead of going directly to a lunar landing, we will endeavor to rendezvous in low Earth orbit with one or both of our lunar landers, test out integrated operations between Orion and the landers, ECLSS systems, even to the extent possible, if we can get up development components of our XEVA suits to test out vehicle interfaces, even just getting an astronaut in a suit in microgravity, we can learn a lot with the idea that we should be learning. And take this information back to inform hardware development, whether it's in the landers or in the suits before Artemis IV, where we will attempt to land on the moon. We are also, as a component of the strategy, endeavoring to preserve up to 2 landing attempts in 2028. So if we get it inside of the 10-month turnaround time that we would like to see, Artemis II will launch on its historic mission in the weeks ahead. Artemis III will have its opportunity, if we can, by mid-2027, which sets us up for an early 28 and a late 28 opportunity. So that is the approach that we are taking at a very high level. I will tell you, we're not surprising our industry or our stakeholders at this press conference right now. We've been having these discussions for a long time. In fact, I give a lot of credit to NASA and its team. No one at NASA forgot their history books. They knew how to do this. They've had plans like this for a long time. Now we're putting it in action. We had a chance to have these discussions across all of our industry partners, all of the prime contractors on the SLS vehicle, both of our HLS landing providers. Everybody agrees this is the only way forward. And I'll say had similar conversations with all our stakeholders in Congress, and they're fully behind NASA in this approach. They know this is how NASA changed the world, and this is how NASA is going to do it again. With that, I'll hand it over to Ahmed.
And we might return to that press conference and hear some of the other speakers later in the show. But now, Richard, have you ever seen a photograph of Neil Armstrong, the first person to walk on the moon, actually on the moon?
I mean, I assume I have. He obviously had his helmet on at the time.
You've seen the picture of him reflected in Aldrin's helmet?
Yep.
Yeah.
Yep.
Okay, but have you seen an actual photograph taken by Aldrin of Armstrong?
No, I don't think I have.
Okay. Well, it does exist, but it's very hard to find unless you know where to go. Look, like on my computer hard drive. Instead, we have that famous picture of Aldrin standing on the moon. Oh, well, that's the way it went. I think now, Richard, it's time to turn back time. And we're going to turn back time to 1966. Yes, 60 years ago. Cosmos 110 was launched on February the 22nd of 1966. The Cosmos series of satellites began in 1962. Most of them were military photo reconnaissance, communications and navigation satellites, but sprinkled among them were some scientific missions. One biological satellite was Cosmos 110, which carried 2 dogs. It was launched on 1966 February the 22nd. 3 weeks later, we heard this report on shortwave radio.
The Soviet news agency, TASS, says the 2 Russian dogs launched into space 3 weeks ago have now been brought back to Earth. They went several hundred miles higher than any man has been on a space flight to test the effects of radioactivity. The dogs were fed by food pellets placed automatically in their stomachs at regular intervals. TASS says the dogs are in good condition after the flight.
Later that day, the Voice of America gave this report.
TASS reports that the 2 Soviet space dogs launched into orbit on February 22nd are back safe and sound on Earth. The Soviet news agency said the dogs returned to the prescribed area after flying around the globe for more than 3 weeks. They flew higher than any being, some 900 kilometers above the Earth, and pierced many times the deadly Van Allen radiation belt. Space travelers will have to cross the belt to get to the moon and other planets. The TASS announcement said medico-biological data received as a result of the flight gave detailed information about the reaction of animal organisms to prolonged.
Still later, the NZBC from New Zealand reported the landing and repeating speculation of a Soviet manned flight.
Russia's space dogs, Blackie and Breezy, have returned safely to Earth after flying for 22 days through the hazardous Van Allen radiation belts. They are reported to be in good condition. Blackie and Breezy are believed to be trailblazers for an early manned flight, possibly also through the Van Allen belts. There have been persistent reports that Russia is planning a new manned flight with several spacemen and more than one ship before the end of March.
Next day, the NZBC later in that same day, in the evening, the NZBC updated that report.
The Russian space dogs, Blackie and Breezy, have landed safely after flying for 22 days through hazardous radiation belts in space. But they suffered from irregular heartbeats toward the end of their trip. The Russian news agency TASS says scientists are working hard on the information collected during the 330-orbit flight. It says they plan to publish their findings.
Next day, the NZBC reported the launch of Cosmos 112.
Russia yesterday launched Cosmos satellite number 112, one day after bringing down the space dogs Blackie and Breezy in Cosmos 110. TASS, the official Soviet news agency, says Cosmos 112, which carries scientific equipment, is the third Cosmos satellite launched in just over 3 weeks. A series of Cosmos shots usually precedes the launching of a manned Soviet space vehicle.
What the NZBC, nor anyone else outside of the Soviet Union, did not know was that Cosmos 111 was a failed mission to the Moon. It failed to leave Earth orbit. 30 days later, on 1966, March the 31st, Luna 10 was launched and succeeded in entering lunar orbit. And Cosmos 112 was a photo reconnaissance satellite, not a scientific mission. World attention focused on the dogs, as in this Voice of America report.
The Soviet Union's space dogs appeared on television in Moscow last night. One of the two dogs, who spent 22 days in space, appeared so tired and sleepy that he sprawled out restfully through his 5 minutes on the screen. The other dog managed to stand with the help of a laboratory worker. TASS news agency reported that a group of space doctors and laboratory assistants examined the dogs yesterday, and they appeared to be in good shape. But they added that the data transmitted to Earth will require considerable processing. Meanwhile, the Soviet Union launched another unmanned Earth satellite, Cosmos 112, to study conditions for manned space flights.
Again, note the incorrect speculation on the purpose of Cosmos 112. Now, of course, Radio Moscow could never be trusted for accurate reports, but in the case of Cosmos 110 was a reliable source of information.
To Radio Moscow broadcast.
The Cosmos 110 Sputnik, with 2 dogs on board, performed a 22-day flight at a height of 904 kilometers.
Living beings have never yet risen to such altitudes. After the flight program was completed, the ship was landed in a predetermined area. Its passengers, the dogs Breezy and Blackie, are feeling fine. It has been officially announced that the experiment was carried out to study the action of cosmic radiation and the radiation belts on living beings. It is a very important problem for man's future interplanetary flights. You have been listening to our broadcast for English-speaking listeners in Africa. Our daily evening programs in English begin at 14:30 GMT in the 19, 21, and 31-meter bands.
Voskhod 110 was Cosmos 110 was a Voskhod type of craft. The speculated test of a new manned type of spacecraft, later known as Soyuz, did not happen until November of 1966 with the flight of Cosmos 133. After one more test flight, Cosmos 140, in February of 1967, the first manned flight was in April of 1967. That flight ended tragically when Soyuz 1's parachutes did not open up. On other look-back news, by international agreement, the International Telecommunications Satellite Consortium was formed in 1964. One of the early decisions was what type of satellite should be used. One choice would have been to use the low-orbiting Telstar type, another the geostationary early bird type. 60 years ago, a decision was made.
Stewards. The satellite communications system to be in operation in 2 years have been agreed at a meeting in Washington. It was decided that the American early bird type of satellite should be used. Several of them will provide telephone, telegraph and television circuits linking the world. The decision was taken at a meeting of the governing body of the International Satellite Consortium last week, but it's only just been made public. Nearly 50 countries have an interest in the consortium. They include Britain and other West European nations, the United States, Canada, and a number of countries in Africa, Asia, and Latin America.
Radio Australia also reported this decision.
Agreement has been reached in Washington on plans to put several satellites into orbit to provide telephone, telegraph, and television circuits linking the world. The decisions on the worldwide satellite communication system using the American early bird type of satellite were taken at a meeting of the governing body of the International Satellite Consortium. Nearly 50 countries, including Australia, have an interest in the consortium. Other members include Britain and several West European nations, the United States, Canada, and a number of African, Asian, and Latin American nations. A spokesman for the Overseas Telecommunications Commission said in Sydney that Australia could be getting telephone and telegraph communications via the satellite system by the end of next year, and television programs by the end of the following year. Everything would depend on the success of the satellite launching programs. A ground station to cost perhaps $5 million would have to be built in Australia to receive signals from the satellite.
And how things changed because of Intelsat. Now, another look back. On 1965, November the 12th, the Soviet Union launched Venera II onto a trajectory towards Venus. 4 days later, Venera III was launched. 60 years ago, last weekend, we heard these reports from the NZBC, the BBC, and the VOA.
Russia has landed an unmanned spaceship on Venus after a 3.5 months journey from Earth. It's the first time a man-made object has landed on another planet. The TASS news agency says the 1-ton space probe, named Venus 3, put a Russian pennant on the planet, but it's not clear whether the vehicle merely crash-landed. As the Russian probe plunged into the thick cloud that covers Venus, its signals to Earth stopped. But the landing gave Russia another notable first in the space race.
A Russian spacecraft has reached Venus, and the Soviet news agency says it planted a Soviet pennant on the surface of the planet. The spacecraft, called Venus 3, was launched last November.
News says it has placed the first object from Earth on the planet Venus. A TASS news agency announcement said the vehicle, named Venus 3, reached the surface of the scorching planet after a 106-day voyage through space. TASS said the flight covered approximately 38 million kilometers.
With the spacecraft Venus 3, America's National Aeronautics and Space Council says the Russian feat is likely to go unrivaled for many years, as America has no plans to put anything on Venus. The director of Britain's Jodrell Bank Radio Telescope, Professor Lovell, says the landing of the spacecraft was a vivid technological achievement.
The Soviet spacecraft Venus 3, after 3.5 months' journey from Earth, has reached the planet Venus, carrying with it a pennant bearing the device of the hammer and sickle. From Moscow, Eric de Mornay sends this report.
According to TASS, the spacecraft made an accurate encounter with the planet thanks to a successful in-flight correction of its trajectory, which was made on December 26th. Throughout the flight, radio contact was maintained with the spacecraft and scientific information was received back from it. However, in the very final stage, before the point of impact, there was no radio contact. It is not stated by TASS whether this was due to any technical failure, but it could be because the spacecraft failed to withstand the enormous surface temperatures of the cloud-enveloped planet. Meanwhile, a second spacecraft, Venus II, which was launched last November 12th, has passed the planet at a distance of 15,000 miles. The trajectory of this spacecraft was not altered in flight, and TASS says its passing of Venus at a prearranged distance was assured by the accuracy of its original launching. The experiments carried out with the help of Venus II and Venus III, says TASS, have provided the answers to a series of interplanetary problems and much new scientific data which is under analysis and study. The news of the two Venus probes has come in a particularly active period of the Soviet space program. It's only a month ago that Luna 9 successfully sent back the first pictures ever taken on the surface of the moon. And another spacecraft, Cosmos 110, is still spinning in its elliptical orbit round the Earth with the two dogs, Breezy and Blackie, on board.
This is your community radio station, 88.3 Southern FM.
Where on the Space Show we are looking back time, turn back time 60 years. The Gemini 2-man missions were a series of technology development missions to prove out the techniques needed for the Apollo lunar missions. 60 years ago, Gemini 8 was being prepared for an ambitious mission. This special English program from the Voice of America explains what was planned after Gemini 8 docked with the Agena D rocket. I recorded this off shortwave radio.
America's space agency is going to try to make a spaceship and a rocket meet and join in space next week. This is called a rendezvous and docking in space. Space scientists have chosen an Agena rocket and the Gemini 8 spaceship to do the job. First, an Agena rocket called a target will be sent up to circle the Earth. 100 minutes later, the Gemini 8 spaceship will be sent up to circle the Earth. The two spacemen, Neil Armstrong and David Scott, will try to meet the Agena target, or rendezvous with it. After they have met it, they will try to join the Agena target. In this way, the Gemini spaceship will join and leave the Agena rocket 4 times during the 3-day flight. This kind of training, meeting and joining a target in space, is necessary for long trips into space. There is another kind of training that is necessary before men fly to the moon. Spacemen must learn how to get out of their spaceship and work in space. No one knows what might happen when a spaceship is deep in space. Small space dust or some other hard material could hit the ship and make a hole in it. Such a hole could be fixed by a man leaving his ship and going outside to fix it. And so, during the Gemini 8 flight, spaceman David Scott will open the door on his side of the Gemini ship and leave the ship. This will happen during the 2nd day of flight, about 13 hours 10 GMT.
The sun will be rising in front of the Gemini 8 spaceship as Scott opens the door. The Gemini ship will be sailing over the United States while joined to the Agena rocket. David Scott will stand up in his seat. He will tie himself to a life support line that is about 8 meters long. The line will feed oxygen to him, and it will also tie him to the ship. Before he leaves the ship, he will get a camera and put it in front of the Gemini spaceship. The camera will take pictures of Scott as he leaves the ship and moves in front of it up to the Agena rocket. He is now ready to leave the ship to do many jobs. He will not get back inside the ship for more than 2.5 hours. By that time, the Gemini ship will have sailed 1.5 times around the Earth.
Scott's first job will be to move himself up to the Agena rocket in front of the Gemini spaceship. The camera will make pictures as he goes. There is a piece of equipment on the Agena that scientists put there before the rocket went into space. The equipment was built to capture micrometeoroids. Scott will look at the equipment and open it so it can capture micrometeoroids. The equipment will stay there until a spaceman from a later flight brings it back to Earth for scientists to study. Scott will leave the Agena target and move back to the camera in front of the Gemini ship. He will put new film in the camera, then turn the camera around so it points to the back of the Gemini spaceship. Scott will then move to the back of the ship to do his next job. This is a working job. He will use a power tool to loosen metal screws. This sort of test will show if a man can work in space to fix a broken spaceship. Scott will move toward the back of the ship to a working area. He will find a piece of metal with screws in it. He will also find a special power tool. He will use the power tool and loosen the screws from a piece of metal. He will turn the metal over and screw it back in its place. By this time, the sun will be setting. But before it goes down, Scott will climb into the back of the Gemini ship until night passes. 45 minutes later, the sun will rise and Scott will begin his other work in space.
During the 45 minutes of night, David Scott will put on his back some special equipment. And as the sun rises, the command flyer, Neil Armstrong, will make the Gemini ship leave the Agena rocket. The ship will move about 18 meters from it. David Scott will then move up to the front of the Gemini ship. He will get a longer line and tie it to himself so he can move farther away from the Gemini spaceship. He will also get a special little hand rocket gun. This gun will help him move around faster in space. David Scott will move slowly away from the ship, meter by meter. When he is at the end of the long line, about 22 meters from the ship, Neil Armstrong will fly the ship up to him. Then, as the ship gets near to David Scott, David will begin to shoot his rocket gun so he can move toward the Agena rocket. At this point, the Agena will be in front and the Gemini ship 15 meters behind. Spaceman David Scott will be following, tied to the ship by his long lifeline. Later, David Scott will climb back inside the Gemini spaceship, and other tests will begin.
After David Scott is back inside the Gemini ship, Neil Armstrong will fly the ship up to the Agena and join it again. Before the Gemini ship returns to Earth, it will have met and joined the Agena rocket 4 times. The Agena will stay in space long after the Gemini has returned. Scientists plan to use the Agena rocket in future flights. It will still be there when other spaceships go into space. They can train by meeting the Agena and joining to it. The 2 men will also do other work during their 3-day trip into space. Many of these will be done with cameras and television cameras. Communications tests will be made between ground and the spaceship, and there will be many medical tests made on the spacemen themselves while they are in flight. Before the Gemini flights end, the Apollo space flights will begin. The Apollo ship will carry 3 men into space. They will also train in space. They will get ready for the 3-man trip to the moon before 1970.
Well, things went seriously wrong on the Gemini 8 mission. Indeed, very nearly disastrously wrong. Tune in to next week's The Space Show to find out what happened. Now, The Space Show. We have a home on the internet. Yes, you can find us on the internet. It's space.southernfm.com.au. And there you can find more than 2,200 features for your listening enjoyment. Oh, and I've got a few photographs as well. And also 230 files following the Apollo 11 mission. That's up there for you to look at as well. So once again, visit space.southernfm.com.au. Well, I'm Andrew Rennie. This has been The Space Show. Thank you, Richard, for your help on today's show. Well done.